similar to problem number 5. So for problem number 9, we have x of t is equal to arc sine of t over 4. Okay, and we want to evaluate. What's it say? We want the tangent, the velocity. So this is the position equation. And we're asked, what's the velocity at 3 seconds? Well, we know what we need to do, right? We need x prime. So we need x prime of t. Well, there's a couple of things we need to do. We need to know that if we let u equal t over 4, right? That's the same as 1/4 times t. So then if I take u prime, I just get 1/4. Okay? So now arc sine, the derivative of arc sine, if it's sine of u, would be how would I write that? Wait, I'm looking at the wrong one. Well, if I derive it and I do the really long way of doing it, what's the shortcut? Isn't it just 1 over the square root of 1, is it minus u squared, right? So I'm going to write it out first and then we'll plug it in. And then we have to tack on u prime. Okay? Now, when we did the example, Mr. Adams proved where this relationship comes from, which is good. You should know how to do that. But truthfully, we're going to just memorize this. Okay? So now because I've made u 1/4 t and u prime is 1/4, now I just plug it in. And so I get 1 over the square root of 1 minus u, which is 1/4 t squared, times the quantity 1 over 4. So then x prime of t is equal to 1 over, and the 4 goes to the front, 1 minus, and 1/4 squared is 1/16, right? T squared. Okay? Now you could clean that up a little bit if you want to. If you want to. But we don't need to, because really the next step is to evaluate that at 3. So what we've done is, this is my velocity equation, right? The derivative of the position equation is the velocity equation, and I want to know what it is when t equals 3. So I'm just going to evaluate this when t equals 3. So I'm going to say 1 minus 1 over 16 times 3 squared. So that gives me 1 over 4 times the square root of 1 minus 9 over 16. Okay. What's 1 minus 9 over 16? Isn't it 7/16?
Yeah.
Yeah. All right. So I'm gonna rewrite this because we're gonna need a little more room. So what we're saying, this is where we're at.
Okay, how'd you get the 9?
3 squared.
Oh yeah.
3 squared.
Okay.
So now when I subtract that, 16 over 16 is the same as 1. So 9 from 16 is 7 over 16. Now I could think of it like this. 1 over 4, the square root of 7, right, times the square root of 1 over 16. You guys with me on that so far?
Yeah, and then can't you take this?
Yeah, so that just becomes 1/4. So I have, and I'm writing out each step so that way you guys can see. So now I have 1 over 4 times 1/4, right? Because that comes from this. The square root of this is this, times the square root of 7.
So then it's 1.
Yeah, so then we get Now, in calculus, this is going to be the tough part. You were taught in algebra, or maybe algebra 2, that what you need to do is you need to rationalize the denominator. But in calculus, we say we don't always rationalize the denominator, but sometimes we do. Do you guys see any variables, or do we have an actual numerical value?
We have the numerical value.
We have a numerical value. So whenever we have a numerical value, we want to rationalize the denominator. So we're going to hit the top and bottom with the square root of 7. That gives us root 7 over 7. So that's technically the answer. Any questions?
So rationalizing just means that you don't want to square root on the bottom.
Yes.
Okay. But you
Yes.
can have it on the top.
So like, let me give you an example. So here we took the derivative. Now I could have multiplied this by the conjugate and did a bunch of fancy stuff, but we normally don't do that in calculus because we're going to plug numbers in at some point.
Okay.
So it's okay to have a square root here.
So you just wait until the last.
Wait until you get the number and then do it. Yeah, that's what I was trying to say. You said a little better than I did. All right, so this is the final answer, though. All right, right here. Boom. So what did I just do? The particle was in motion, and its position was based on this equation. Okay? We skipped forward, and we found that the velocity was based on the derivative of that position. Okay? What we were really asked was, what is the velocity of the particle at 3 seconds? So by plugging the 3 into that, I got that the velocity was root 7 over 7 units per second. Okay? Because I don't know if the textbook said if it was meters or feet or whatever. Any questions on that?
No.
No?